Hello, everyone. Good morning. I just wanted to get a mic check out there. If everyone can hear me, if you could just type in the questions. All right. Steve is on it. Thank you, sir. And we'll get going in a couple minutes. There's some other people filtering in here. And there's another question. I think the audio, it should come through your computer. If not, then you'll have to dial in by phone. But it should come through the computer. There's a question out there from Benoit. How you doing, Benoit? Yeah, if you can't hear it through the computer, then just if you go up to the audio tab, there's a dial-in number with an access code.
I just changed it, Matt, so there is now an option for clicking computer audio, so hopefully that takes care of it.
Oh, okay, I see that there now. Cool. Very good. So we'll get going in 2 minutes. Okay, we're gonna get moving on here. Good morning, everyone. Thank you for chiming in here and spending a little bit of your morning with us. This is our webinar on the digital factory featuring the Figure 4 modular 3D printing system. And we'll talk about everything about this machine. We're also going to have a live demonstration of the software that controls the system, as well as a live walkthrough of the actual machine. So we have two other gentlemen on the line with us. I'm Matt in the upper left-hand corner. Also on the line is Pat Harrington. He'll be doing our live demo of the software. And then also Anthony Barrick. He's down in our Harmony office in front of the machine, anxiously waiting, to walk through the machine with you. He's got a webcam set up, and we'll show you the machine. So what we're going to talk about is the Figure 4 solutions. And what these machines are really dubbed as the that fit really in the digital factory are digital injection mold machines, which would really kind of perk your ears if you're in the injection mold industry. and we'll talk about why they're called that and what makes them very competitive in the low volume, even to mid volume injection mold production setups. The way that this product line works, it's fully scalable to whatever production needs that you are facing. Which means at the beginning we have the Figure 4 standalone. This is just a single machine with a single print engine, and it's very, very fast. All these machines are very fast, and we'll talk about just how fast they are. So you start with this standalone, and this is good for anywhere from 500 to 1,000 parts per month. And then you move up to the modular. The modular is very interesting, and this is the machine that we're going to be focusing on mostly, and the machine that you'll be seeing. Hold on, there's some other questions. No sound. Okay, good. Okay, we got sound. So with the modular machine is interesting because you can add print engines to a single controller, and you can add up to 24 of the print engines in a running off a single controller. What that means is that you can add these as your production needs grow. Also, your material needs grow as well. Each of the print engines, they can run a completely different material. So this gets really exciting because now you start to think about parallel production is the name of the game there. And then you move up to the Figure 4 production, which is an amazing machine. What this has is you basically load in your part file, your digital file, and each one of these modulars has 4 of the print engines within a single cell. And then it also has a UV cure and a wash station for you, and out comes your finished parts. So you can see this is like a digital injection mold assembly line. In goes the file, and out comes your parts. We're talking about production numbers up to 1 million parts per year. This technology is not new. In fact, it was invented by the inventor of 3D printing, Chuck Hall, in the mid 80s. And this is actually it's called Figure 4 because that was the figure for the patent office that described the technology. And if you look at his diagram over here, Chuck Hall, by the way, is involved with this whole Figure 4, obviously, and he's still inventing and part of the 3D systems innovating team, technology team. So if you look at the figure here, 21 is the reservoir material, and then over here is your material vat of liquid, and then this is the build platform, and this is your part here. The part actually will build upside down, and down below here is your light projector. So basically the light, and we'll find out why this is very powerful in this technology, but basically it's a light at a certain wavelength, and when the part comes down and it rests within the bath, the light will shine on the entire area of the liquid, and it will cure where it needs to, where the part is, all at once. So it doesn't matter if there are 2 parts or 1 part or 3 or 4 or even 10, it will cure the entire layer all at once. So what this yields is awesome accuracy. I will see some CPK values coming up, faster builds, and amazing detail. So this is fully integrated solution from 3D Systems. They manufacture the printers, the materials. We'll see the software, which is a very powerful software, and the service is all handled by us and also 3D Systems. So it's fully integrated, and it's a full turnkey when you purchase the system. So what can it do for you? There's really two that I want to focus on right now, and that's accelerate your time to market. And the first bullet is really something that I don't think has been exploited that much in the industry, and that is a true same-day print and ship, which means that your customer calls you up in the morning and sends you the file. You can literally print it that morning and ship the same day. And that's a whole new level of, if you're an OEM, accelerating your time to market, or if you're a service bureau and you can advertise same day print and ship. I think that's a very powerful business position for service bureaus and contract work. The other one is supply chain. And you may have read, stories out there that how 3D printing will affect your supply chain. And really, that is true today, like any other day, except with the focus on what is, really going on in today's markets and events. And I think as we get past what's happening now, a lot of companies are going to reevaluate their supply chain and really, take note on where your parts are coming from and begin, to take control of your supply chain. And one of the greatest tools is 3D printing. 3D printing can fit anywhere in your design cycle, as well as tools and fixtures, and really across the board. If you think of an iceberg, we're just at the tip of an iceberg in manufacturing and how 3D printing can fit into manufacturing. There's just a ton of uses, and as materials and the economics of 3D printing, it's getting faster, it's getting cheaper. The materials are getting to be usable as opposed to just a toy in your hand. Now they're actually able to be used. It really becomes a powerful position, for a company to look at adopting and add it to manufacturing program. So let's talk about how fast this thing is. And this thing is fast. So basically, we're at 100 millimeters an hour. That's 4 inches in Z height every hour. And that's for the tough grade 10. Each of the materials have their own printing speed, but the tough grade 10 is the fastest. So you start to think about, some of the other technologies, FDM, which is a traditional 3D printing, where it has to trace all the geometry of the part, and if you add another part, it's just going to double your cycle time. But here, if I have one, or if I have however many are here, about 100, it's all going to take the same amount of time. Because if we think about the light again, the light is curing the whole layer all at the same time, no matter if it's one part or 100. It's not only fast, but it's also accurate and repeatable. Repeatability is huge with this machine. If you look at the CPK values, if you're not familiar with CPK is a repeatability on your process. And automotive uses this a lot, and they use it to gauge the repeatability of their processes. So if we take the figure 4 as a process, or a number of figure 4s as a process, which is what these numbers are based on, multiple machines. And then if you look at the numbers, okay, what do these mean? If you take 1.33 as a CPK, that's like an average value of a CPK. Your process is okay. If you go to a 2.0 CPK, this is considered an excellent process, repeatability, as far as repeatability goes. And if you look at what we're yielding on these machines, we're over 2. Over a 2.0 CPK on these machines, which is a huge milestone in 3D printing. Really, before, CPK values were never assigned, to 3D printing processes. But here, because the process is very simple, and the materials are very stable, we're able to achieve these high repeatabilities on this process. If you look at what the base unit is, now the base unit is what you order at the very beginning, and it will come with the controller as well as one of the print engines, and then a UV curing unit. And then as your production grows, you add these auxiliary printers up to 24. And if you just think about what that is, 24 of these lined up across, all printing at a very high print speed as well as a repeatability. You could begin, really to see why this is dubbed the digital injection molding machine. You could also do part texturing, and this I like these the pictures because it not only tells you what kind of feature resolution that you can expect out of these, but it also shows some parts that you can injection mold. Some of these textures are very difficult. They got to be EDM'd into the part or do some kind of etching either after the injection molding or right in the injection mold itself. And now we can do this right inside the 3D printer and do all the texturing right out of the printer. As far as materials go, I think the materials is really what makes this technology work. And I'll tell you why in the next slide. But basically, this is the material lineup here. We have some prototyping materials, some production. We also have some application specific, like eggshell molding is really neat. That it's basically a sacrificial eggshell, and then you pour your RTV molding in there, and then you just break it away, and then you have your part. So it's a creative way to do some low volume RTV molding. And then we also have some medical materials also. So this is a standard material. It's a tough black 20. It really does look and feel like injection molded ABS. But on the next slide is really, I think, where the magic happens. So if we look at the outdoor weathering, typically UV cured material degrades over time. So this is a 12-month line right here, a 1-year line. And you can see, like SLA or anything UV cured eventually degrades over time, and that's because it's getting hit with the same radiation UV from lights and sunlight and everything else that was used to cure it. And then eventually it just breaks down the part, except for this machine here. If you look at the figure Tough Black 20, you can see very minimal degrading over time outdoor. Why? And the reason is, if we go back to the light that is used to cure the material, the light used, the projector light, is at a specific wavelength. It's a certain nanometer wavelength. And what they can do with that is they put UV stabilizers inside the material, and it matches up with the wavelength of the light, and now you have a UV stable material and use part, coming out of the printer. Which, for me, I think this is really one of the first on the market. If you look at indoor, same idea, traditional, okay, about a year, then it starts to taper. On this machine, we're still holding strong up until even 5 years of exposure of UV light. So we're talking about end-use parts here. We're not talking about the parts that will eventually crumble in your hand. These parts are end-use and will last. So again, it's just another addition onto the high speed. Also the CPK, along with those two and their end use and UV stable, you really have a really powerful machine. We also have, in the same machine, you could change out the material, and then you can go to a completely different material if you're going for high temperature. If you look at the temperature, the heat deflection temperature, we're 300 degrees Celsius, and that's very high. So if you have applications that need high heat, you can look at this material. We also have medical material as well that can withstand the autoclaving process, cleaning, sterilizing, and these are biocompatible, which means it carries a Class 6 certification that can come in contact with the skin. So very powerful materials. This is just an example. You could do a multi-material. So you have like a rubber gasket here, and you have the clip here, and then a connector up here. And this just gives you examples of what it takes as far as the time. I mean, look at the time. 12 of these parts in an hour, 19 minutes, 20 cents a piece. Before I kick it over to Pat, I just wanted to also mention we also have design for additive manufacturing courses, and these are for everyone. If you already have additive in your facility and want to learn more, or you don't have additive and you want to learn what it's all about, we have all different classes. We have the fundamentals, which we cover all different types of technologies. We have the plastics, the metals, more for the business owner, and then we also have a custom course as well. We can do these on site at your facility, or once everything opens up, we'll have some dates already scheduled to come into this office first. And so I think with that, I'm going to kick it over to Pat, and he's going to talk about 3D Sprint, which is the software platform that not only slices, it does a lot of other things too. And so Pat, if you want to take control.
All right. Able to see my screen? Matt?
Yeah, I can see it.
Okay, thanks. All right, so as Matt mentioned, let me take you through the 3D Sprint software. This is 3D Systems standardized software that they really use to run most of their printers. You can see here that we're going to look at the build envelope for the Figure 4 modular. Down here in the bottom right, you're going to see the build envelope for our machine. So you're going to notice that the Z dimension is really the largest on this particular modular unit, with an X and Y under 5 inches, and then the Y being about 2.7 inches. So first things first, with choosing or to set up a build in this software, we're going to come over to our printer tab and select the printer that we're going to set up our print for. And then, as Matt mentioned, there's quite a few different materials that we can accommodate in this technology, different resins. The one that we use on our demo unit in Pennsylvania is a Pro Black 10 material. So we'll select that. And then here you're going to see that we have quite a few different options for different print modes that we can run this material. And so anywhere from 10 microns, which is an extremely fine layer height in 3D printing, up to 100 microns. And this will affect print time as well as the surface quality of your prints, as well as the accuracy, mostly in the Z direction of your prints. So we found that 50 micron is a nice middle of the road option for optimizing speed and quality. So we'll go with that one. And then our last option here, which is certainly something you can adjust and play with, are the different build styles. So we have 3 different ones. We have draft, standard, and premium. And this really controls the amount of time that it takes to cure each layer, which can affect your surface quality. So draft will be give you the fastest print times. Premium will give you the slower print times, but presumably the best quality, surface quality on some parts. Whereas again, standard is going to be a nice middle of the road option between quality and speed. So those are your options there. Now let me pull in a part and we'll take a look at for Figure 4. So first thing I'm going to do is I'm going to bring my part inside the build envelope here. So we'll use my orient command. And the reason I picked this part is because this is a part with a few errors in it. You'll see this yellow hue around the part, and then up in the top right-hand corner we have a red exclamation point next to it. This just means that there may be a few issues with this part, and this is something that 3D Sprint can handle very easily. So the way that this software is constructed is the workflow setup is 3 tabs. A prepare tab where you can do some advanced file preparation and repair or editing. The print tab, which you're seeing right here, which is really setting up your parts within the envelope of your printer. And then the Q tab is where you eventually send your jobs over to the printer and manage which ones are prioritized. So let's take this part and go back 1 tab to the prepare tab. You'll see a slew of different editing options here that we'll cover in another one of our webinars a little bit more closely, but for now we'll click on the Fix tab, and it's going to do some analysis and see that this part has some duplicated faces and it also has some small components. Nothing too crazy, but if we click this Fix command, the software is able to take care of those and get it to a point where it will very likely print correctly. So we have this nice green check mark now. Software's comfortable that this is going to work out well, and we'll send it back over to the print envelope. So nice and easy there. The next thing that we're going to talk about is orientation strategies for this technology. So with other printers, maybe like FDM, printers like that, you typically want to orient your parts just like you're seeing here, where it's a nice flat part. You're getting a lot of contact area on the bottom surface, and that bodes well for other print technologies. For Figure 4, it's almost the opposite. So what we're able to do in this software is we can come over and turn on our down-facing angles, This is going to show us any surfaces that will require supports. So just like other 3D printing technologies, this figure 4 technology also uses supports. So red, like you're seeing here, is a surface that will require quite a bit of supports. And then, as we go to orange and yellow, supports become still necessary but less critical. What we're going to do next is I'm going to turn on my clipping plane here, and we're going to see as we're moving through this part, all of a sudden, we hit this as our first layer where the part begins. This is a cross-sectional view. And this is considered quite a large surface area for the figure 4 technology. It's not to say that it's impossible to do, but it's not quite ideal. So what we like to do on a large majority of parts, medium to large size that can fit in this, is we'll come over and we'll actually orient our part on a compound angle. So I like to play around with sometimes 30 degrees in the X and then maybe 20 degrees in the Y direction. That's just a starting point. And what you'll notice is underneath, areas before that were dark red that required supports, well, now they're switching more towards orange and yellow. So will still be necessary, but not quite as critical. Now let's go through the clipping plane and see how we've reduced our layer by layer cross-sectional area, which anytime you can reduce that, it's going to increase the quality of your prints. So now, rather than that entire flat cross-sectional area, we're really working through smaller cross-sections as we build up this part. And this is just going to ensure that the adhesion force, as our build plate dips down into the resin tray and makes a very low contact with the film underneath, when the tray pulls up, it needs to overcome this adhesion force. And the lower surface area that you can do, the better results that you get. Next, what we'll talk about is supports. And I'll touch on this a little bit in more detail on another part I'll show you. But we have a few different presets that we can use for how the supports are going to connect to the part. A fine flat tip, a general flat tip, and a general round tip. So really what those dictate is how much those supports adhere to the part, and also probably how tricky they may be to remove after printing. So even still, they're not too bad removing. It's almost like a Velcro, like you're pulling that away. But you can see here that they really taper up to small points that can be broken away from the part after printing. So all of this area underneath is generated with an automatic support algorithm. Software decides where it needs it, and then it's often advised that the user goes in and just makes sure that there's no additional areas that you wanted to beef up. So let's do a quick estimate here. How long would it take to produce this part on the figure 4? Okay, we're at 49 minutes. If I could fit another one right next to it, it would still be 49 minutes, because as Matt said, it's curing the entire layer simultaneously. Now, if we wanted to change our build time, that would be very easy by going through and playing with our settings that I noted before, which are layer height as well as build style. Let me get rid of this part and bring in another example that really speaks more to getting into actual digital production in some cases. Let me bring this part into the build envelope here, and let me use the orient command here, which is going to allow me to choose the surface and snap it so that the part is perfectly vertical. On a part like this, it's not quite as necessary that we orient our part on a compound angle like we did with our other part, because the part's much smaller. It's a thin wall part. Cross-sectional area really isn't going to be too large any way that you slice it. So there's a decent chance, a very decent chance, that if we were to print this part in this orientation, it's going to come out just fine, and it's actually going to produce probably the most circular part as well. So we'll give this a shot. If we look underneath, we're going to see some areas that will require some support material. But let's see what we can do in terms of optimizing throughput of this part in a single build of the Figure 4 modular. So let me take a top view here, which will help me orient my parts a little bit more. I'm going to move my part to the bottom left-hand corner. And then I'm going to use this copy feature, which, it'll allow you to copy parts, but there's also a linear array feature, which is interesting as well. So what if I took this part and I made 10 copies along the x-axis? And then I took the same thing and did, let's say, 6 copies. And I'm just changing the distance between all of my parts here. So let's see what this would look like. All right, so I just have to pack them in a little bit tighter. Before I do that, let me go back and I wanted to touch on something else before I did that. And let's go ahead and generate our supports for this part, just like we did with the last part. Okay, so yes, it's putting some supports in places, but sometimes the algorithm on small parts like this, it may miss a spot. That's not the end of the world, because what we can do is we can go in and we can modify where our supports are being constructed. And depending on the color that we're seeing on the underside, this will kind of dictate where we want to put those. So very easy to just delete supports that are maybe in an irrelevant spot, or that you want to kind of zero in on those a little bit better. And then add supports. So maybe we'll add some additional supports on these overhangs. We'll add some additional supports on the underside. And then this round at the top would probably be good to support as well. So we'll toss some additional supports in there. Then we'll just hit update, and then it will add in those areas. Nice and easy. So that's the support editing. It's very simple. You're just going in and telling it where to add and remove supports. Now let me go back to where we're trying to optimize this build for throughput. Let me go down here. Let me do another linear pattern. We'll do 10 in the X direction. And then we'll do 6 in the Y. Let's see what this looks like. Okay, so we're able to fit 60 parts in an XY envelope of this machine. And in terms of time, we're going to get 60 parts in the same amount of time that we would get 1 part. So that's awesome. Now, we can even go a step further in some cases, and it's really a function of your part geometry and how much support your part will require, if this is a possibility. But for a part like this, very feasible that we could go this next step, which is taking advantage of the full Z extent of our envelope on the Figure 4 modular. So let's take this full stack, or this full nest of 60 parts, and let's start stacking these parts vertically. So how many can we fit here? Let's see what 16 vertical stacks looks like. And this may take a second just because we're talking about a lot of parts here. Basically, what this is going to entail now is not only are you going to have supports on the underside of your part where that's required, you're also going to need to be okay with the fact that you're going to have support structures on top of your parts as well, which is going to support the stack that's directly above that part. So if if that's something that you're able to live with on your part, some support scarring on the top as well as the bottom, and your big thing is throughput, getting as many parts as you possibly can, then this is an option as long as your part geometry allows for it. So let's see here. It's done computing, and what we have now is we have 960 parts in a single build on the Figure 4 modular. Now the biggest question is, all right, 960 parts, that's a volume that's typically too large for 3D printing prior to this technology. It would take way too long unless your lead time, accessible lead time, was way out. 960 parts is just used to be untenable. So let's see how long this is going to take on a Figure 4. We're under 5 hours for 960 parts. Now, yes, you will have to factor in that after this print is complete, there's going to be some time that it takes to wash these parts. The wash process really entails an isopropyl alcohol dipping to remove resin. Anthony may talk about that a little bit when he shows the machine. It doesn't take too long for the cleaning with the chemicals. After that, this part's going to go into a UV cure chamber. The amount of time it spends in there is material dependent. For 90 minutes, though, is a nice average. That's the case for Pro Black 10. But as soon as you pull this rack of parts out of the printer, you can put another clean build plate in, hit go, and start the next print while you're doing these post-processing steps in tandem. And the last post-processing step after UV curing would be removing the supports from the part. So yes, I would still need to generate supports on all these parts. I'm going to spare you that time watching the software compute that because there's so many, but the build time will not change. It's still going to be in the right underneath 5 hour range. So this gives you a nice example of why this is, kind of marketed as a digital injection molding alternative for geometries that can fit well within this envelope and work well with this cross-sectional area and the supports that this technology implements. So with that, I think we'll pass it over to Anthony. If you have any questions on the software itself, feel free to put those into the questions box, and we'll make sure to answer those. So let me get over to Anthony.
I appreciate that, Pat. Give me a quick second. I'm going to pull the camera back here so that everyone can see what a complete system looks like. Currently, as you can see here, the printer's printing a part, and it'll move up and down, and every time it moves up and down, it's adding more layers to the print. But I'm going to zoom out. I want to kind of go over the full system with everybody. So just give me a quick second to move the camera. All right, there we go. Can everybody hear me okay?
Yes.
Perfect. So this is our Figure 4 system. This is the modular unit, like Matt said. The Figure 4 unit contains 3 pieces of key components. The first one being the actual print module itself. Like Matt said, this would be the unit that gets linked up to 24 units. So One thing that's really powerful about the Figure 4 is the ability for a manufacturing company, especially if you specialize in injection molding, to be able to link a lot of these printers up and put out really high volume, you know, upwards of 10,000 parts a month when you link a lot of these units. The other big benefit that the Figure 4 modular has is the control module that all the printers run on, and that's kind of the second key component of the system. The computer and control module will allow one operator to run all 24 units by themselves. You don't need multiple people working on the floor to run an entire assembly line of machines. One thing that's really nice about the Figure 4 control module is it is aware of all of the machines that you have and the different materials you have, and it will auto-prioritize print jobs based on the material needs and the time of the print. So in the control module, under the queue and printer status, when you have 23 of these printers linked up together, it will show you the status of every single printer at all times. It will show you, as you can see here, we have one module, but it will show you the module, it will show you kind of a sample of what that current printer is printing. If you click into that module, it'll give you a little bit more info into that specific module, what material it's running, how long that current print is. You can also see all of the job that's currently in the queue for that one module. Now, if you had multiple modules, you would actually see each individual module on the screen. And what's really nice is, when you have a print job that comes in, because the Figure 4 can run so many different types of materials, you might have 10 modules linked together. And each module might have, each two modules might have 2 different materials. So say you're running 5 different materials on 10 modules. When you prep that build in the 3D Sprint software that Pat showed, when you send that part to the print queue, the Figure 4 modular unit will automatically prioritize that print. It'll know what material it's printing. It'll automatically find the printer that has that material available. And it will also find the printer that has the shortest print queue currently to fit that part into your production line. So it's really nice to have when you've got 15, 20 of these printers up and you're pumping out thousands of parts a month. It takes a lot of the work from the operator to have to pay attention to, okay, what do we have available? How much material we have? Do we have that current material on hand? The 3D Sprint software and the Figure 4 control module take care of all of that for you. So that's kind of the second key component of Figure 4. The third component, as Pat mentioned, is the cure oven. This is our cure oven here for the Figure 4 module. Essentially, it's a UV cure oven that runs on a timer. It's programmable for each of the materials that you have. We run ProBlack 10 in our Figure 4 modular, and the ProBlack 10, like Pat said, has a 90-minute cure time. The cure oven gives you 2 different options for curing parts. Like Pat mentioned before, in the modular unit, we can print a full 13-inch stack of parts that might have 900 parts on it. If you're going to print parts like that, when the parts come off the printer, the parts will actually be attached to the print bed, hanging down vertically. You can take that print and put the full stack inside of the printer. Now, let's say you're running a print job and you've got 5 or 6 of these printers lined up and they're all running ProBlack 10 and they're printing out different parts for different customers. Well, 3D Systems has an option for that too. You can take out the stack plate, and 3D Systems gives you a rack where you can put individual parts on each level and cure different parts at different times. So if you've got 4 different builds that all need to be cured at the same time, you can take that stack, put it inside the UV cure oven, hit the button, and we already have it programmed for 90 minutes. and in 90 minutes it'll turn off and your parts will be finished. So that's really nice that they give you a couple of different options for processing parts. Pat had mentioned post-processing parts that have support material on them. And there's kind of two routes you can do that. Depending on the geometry of the part, sometimes you might want to remove support material before you put parts in the UV cure oven. Other times, like if you're printing a full stack, you would just leave all those parts stacked together. Post-process and cure that stack in one piece, and then remove all of the parts individually off that stack. So again, it's just nice 3D systems give you some options for how you want to post-process parts. Another thing I want to point out, Matt Jones had talked about the actual build plate and the way that the printer works, and that the printer has a build tray that is full of liquid resin, which some of you probably saw as the printer was printing. The build plate would come down, go inside of that. So what I'll do is, in our control module, it doubles as a cabinet, which is really nice. This is where we keep all of the things that are needed to run the modules, post-processing equipment, additional build trays, additional resin trays. We keep all that down here. I want to give you a close-up of what the resin tray looks like. So we have a spare resin tray here in case you want to run a separate material. So this is what a resin tray looks like. Try to give you a nice close-up here. It's got a clear film, like Matt had mentioned. The projector, the light, the UV light that cures the material while it's printing will shine through this clear film. The tray here will hold all of the resin that you need. And one thing that's really nice about the Figure 4 unit is it holds a reservoir of material on the bottom, which I'll show you in a second, but it auto-fills material. So it knows when you're getting ready to start a build what the level of resin is inside the tray. And there's a pump in the machine that will automatically take material from the bottom of the machine and refill the tray every single build. So those kind of ease of access things are what makes it capable for one operator to run 15, 20 of these machines at a time. They're very low maintenance. You don't need to go around and refill the trays every single time. The machine takes care of all that for you. It knows if it has enough material. It knows when it needs to refill. And it constantly keeps you updated throughout your production line to make sure that you always have on hand the materials you need to run the job. So that's kind of really nice. The actual part material, like I said, is located down here. In this tray is a bottle of liquid material. There's a pump inside this housing unit that will pump that fluid up and fill the tray. And it will do that before it starts printing. If you're doing a real tall build, it'll continuously replenish that build tray so that you have enough material to finish an entire 13-inch stack of parts. So one thing that Pat also talked about was the speed. So I'm lucky enough that down here at our Harmony office, we have the Figure 4 here. Over the last 3 weeks, I've got a lot of time to print hundreds of parts on this machine. One of the first jobs we did was a stack of 100 parts for this machine. And it is really impressive on what the speed is. So what we have printing on the machine now is actually a medical mask. That's something that's been relevant to a lot of people. A lot of people have been making those kind of masks on FDM style filament printers. And one thing that's really nice is the speed of the Figure 4 unit. So what's printing on there now is this mask here I have, and I'll try to give everybody a nice close-up of that. But it's a medical mask that takes a NIOSH N100 changeable filter on the front. And these are the kind of things that people are really familiar with. And we're able to print this in injection mold quality. We can pop off just one of these masks takes almost exactly an hour to print. And if a lot of people are familiar with an FDM style, they'll know that these kind of masks on that printer take anywhere up to 3 or 4 hours each. So it is really impressive how fast the machine is. The only other additional thing that we don't have right here that Pat talked about was how we post-process parts using isopropyl alcohol. You can use any kind of TPM solution or resin cleaner to post-process the parts. What we use here is a product similar to isopropyl alcohol, and we use it in a parts washer. So when the parts come out, I'll take the entire build tray with the stack of parts, I'll sit it inside of a part washer that agitates the solution, and this does not take long. Typically, I'll leave it in there for 2 to 3 minutes. I'll blow off the residual with an air compressor, and I might do this 2 or 3 times to make sure that I get off all the excess resin that's covered on the part. And once that's finished, I'll just take the parts, blow them off with air, and then they go straight into the UV cure oven. So total time for parts, for something like this mask, including UV print time, we can do 3 masks in about 3 hours. That includes print time and UV cure time. So if you're looking to get into digital production and do high volume parts, which like Matt said is something a little new for 3D printing, the figure 40 unit is definitely the route you're going to want to go for anything over, say, 500 parts and up. If that's the kind of numbers you're looking to do in a week, the figure 4 modules is really good for that. So I'll throw it back to Matt. We'll see if anybody has any questions, or if you guys want to see anything specific. I'll try to get the camera up close and show that to you.
Okay, thanks, Anthony and Pat. Much appreciated. I will open it up to questions now. If you want to type them in the questions box below, and we'll get them answered. Anything on the 3D Sprint software, or anything that's actually on the printer? Any questions? All right. Well, I don't see any questions coming through. You could always give us a call or email, and we'll be reaching out. And there's also a short survey after you close this out. If you could answer those, it helps us to refine this and get better the next time. So thank you for your time, everyone. Really appreciate it. Have a great day and stay safe.
Thanks, everyone. We'll see ya.
Yep, thank you.